It was a good lunch, wasn't it? And it was a good time of fellowship. We had some beautiful singing. Everything's been really good. And now we've got another session I'm going to talk about. Do you know what I'm going to talk about? The rocks, the fossils, and the age of the earth. And so that will be great. My microphone's working and the clicker's working. So it's some of these things. We're still into geology, and I did touch a little bit on biology this morning when I talked about natural selection and that sort of thing, and a bit about the dating. But I'm going to particularly do a little bit about dating methods now, which is, for many people, it's a big issue. And but first of all, I'd like to introduce you to a rock, and one of my favourite rocks. See if it works here. Is it going to work? I'll put it onto the right button, and it'll work. There you go. Somebody sent me this rock. They sent it. They live down towards the bay, and they sent me this rock wrapped up in bubble wrap, and it was and so I've really valued this rock. What do you think of it? Do you think it looks nice? It's a nice colour. And so I got one of the people in the office to photograph it. And this is the lady's hand. She used to be looking after the magazine and that. And I just wanted everybody to see what this rock looked like. And you might be wondering, well, what's the point of that? Well, the thing is, when you turn it over, this is what it looks like when you turn it over. Because when you look at it this way, it looks like it's really old, doesn't it? It looks like it's a rock that could be millions of years old. But then that's why people who were down in the bay, they're walking along the beach, they came across it and they discovered this. Isn't that amazing? And so that illustrates to me, like, the things that we sometimes think are true are not true. And things that we often look at rocks and we think they're millions of years old, and it's not necessarily true. So I'm going to show you a few examples of how we can be tricked by appearances in geology. And geologists make assumptions. And another one is this. You see these various layers. See the layers? And the idea is, that one of these layers formed in 1 year and another one formed in the next year. So even in that little bit, you're looking at probably 50, 100 years of layers that are there. And so when you look at the big embankment that's there, this lady standing alongside the embankment, that must be thousands and thousands of years old. And so that's the sort of impression you get. And geology works that way. People look at it. And here's the example of another part of the same embankment. And you can see the layers of rock. See that great big area of layered rock. Well, the thing is, you could interpret it that way, but we saw it actually, it formed. Somebody was there when it formed. It was a result of a great big volcanic explosion which blasted ash and dust that was red hot out of the volcano. And it was such a big blast, it covered a huge part of the area. And it occurred on the 12th of June, is it? The 12th of June, 1980. Pyroclastic. Clastic means broken pieces. Pyro means hot. So hot, broken pieces of volcanic layers. And it all formed in 1 hour. Isn't that incredible? And so that sort of knocks on the head, or helps us to be aware that we can be misled. And this is the volcanic explosion. It was in Washington State, near Seattle. It was near Portland. It occurred in, not this one, well, this one that's photographed did occur at that time in May. And there were 57 people killed in this explosion. They thought that the explosion was going to go up, straight up, and so they had cordoned off the area. But in actual fact, it went sideways and blasted across. And so I went to Seattle and I went to Portland a number of years ago. And everyone I met would say, well, when the explosion occurred, when the volcano erupted, I was, and they'd explain where they were. And it happened on a Sunday morning, and everybody that was working in the forestry was pretty well, they were at home, going to church, or something like that. And so if it hadn't have been on a Sunday morning, there could have been thousands of people killed as a result of this. So we talked about being prepared, and we talked about, these dinosaur fossils. And did I mention they don't have a label on them? I think I did mention that, didn't I? And that's it's a pretty silly thing to talk about, but it's a key thing. It's a really important concept. And the thing is, the date that you give depends upon the way you look at the world. When I was in Canberra, they've got a national dinosaur museum in Canberra. Or they did have when I went through. It was a number of years ago. And in the museum, they had on the wall, they had this on the wall, which said, "This is how dinosaur fossils form." And so I took a photograph of it. It's been around for a while, this photograph. And so here you got the dinosaur. The dinosaur's died, and it's sinking to the bottom. See, it is. Looks pretty not very well. And then it lies on the bottom. It comes to the bottom, and then it's just lying there for a long time, and it gradually rots away, and it stays there. And as it's lying on the bottom, what's left of it, it gets covered in sediment. So that would take a long time for the sediment to wash into place, and then you get the sediments that's there, and then eventually the area is sort of washed with water and it erodes away, and then somebody discovers a dinosaur fossil. So that's the story that kids learn about how dinosaur fossils form. And so, of course, nobody saw that happen. Nobody's seen it happen. And so it's a story. But has anybody here ever had kept an aquarium with fish in it? You've kept one. Have you ever had one of your fish die? Is that what they do? They sink to the bottom and they just lie there waiting to be fossilized? What do? They bloat and float. That's right. They bloat and float. It's probably not a nice thing to talk about. But they float, and then all the other fish will come along and eat it until there's nothing left, a few scraps on the bottom. So they just don't fall to the bottom and are waiting to be fossilized. As a matter of fact, if you go down to the Gold Coast or you go down to the bay, you don't walk into the water and have all these fish that you're standing on, lying on the bottom, waiting to be fossilized. Because these things are scavenged. They're cleaned up. The environment's left very clean by these scavengers. So what has to happen if you want to make a fish fossil? You have to bury it quickly. It's swimming along very nicely. And you then mix up a bit of cement in a shovel, and you drop it in on top of it like that. And that way, it's buried quickly. It can't be scavenged. And then gradually, it sort of looks a little bit the worse for wear, and eventually, it looks a bit fossilized. And so that's an interesting one. Like even the way they explain how fossils form, it doesn't really fit with what we experience in real life. It all points to rapid processes. Now, a few people have asked about how to get a creation magazine, and the people at the table have got this form. You see the form like this? It's on a board like this, and you just fill it in whether you want 1 year or 2 years, and they'll handle it. You don't need to pay for it today. You can arrange to pay for it after the Sabbath. But that's how you do it. And also, that's the same way. I think a lot of people have got the email news system like that. Okay, what are we doing to next? So I went to a youth group one time. And they'd arranged for me to come to this youth group during the week, one evening. And a lady who's the mother of one of the young people sent me an email. And she asked, could you please answer these questions? My son is going to the university, and he's coming home with questions which I can't answer. So she asked me if I could deal with some of the questions. And I thought I'd put some of the questions up and the sort of things that she was asking about. And I think I mentioned to you, didn't I? Does natural selection prove evolution? That was her question. Another one, is chimp DNA similar to humans? Have you heard that idea? That chimp DNA and human DNA are so similar, that proves that we evolved from apes. That's the idea. And in actual fact, they've done more work on it. And there was an article, or there will be an article in the magazine, saying that it's about 85% or less. There's a huge difference between chimp DNA and human DNA. And another question that came up is, where did all the races come from? Another one, are dating methods reliable? I'm going to talk about that now, dating in a minute. Dating methods are reliable. And where did all the water go? Which is interesting. Where did it all go? But I think already a lot of you have subscribed to how you can get more information. The email newsletter, and the form is out there. You can still fill it in. Ask Wendy or Evan or David about that. And I'm sure you guys are familiar with the website. So that sort of settles how you can get the information. And what I want to do is look at these rocks and these fossils through these different lenses. The Bible lens and the evolution lens. And the really big thing, as I've already said and as we talked about, the big thing is Noah's flood. That's what makes the whole difference. That blows away the millions of years. It makes sense of why there are dead things all over the world. And there's a guy who lived in Holland. He was a building contractor. And he had a dream. He wanted to build a model, a full-scale replica of Noah's Ark. Isn't that incredible? How many people have a dream like that? I want to build a replica of Noah's Ark. And his name was Johannes Huybers. And he did it in 2 steps. He built a smaller version, and this is the larger version. And it was in the newspapers and that, and he showed just how long it was, and he's got a hammer, trusty hammer on his arm there of how he built it. And in Holland, he built an earlier version, and he sailed it down some of the canals which are in Holland. And here you can see it coming down. You see the giraffe sticking its head out. Can you see that? And you could go on board, and you could have some refreshments on board there. And the drawbridge is up. Can you see the drawbridge is up on this side? I think it is, so that the ark can go through, and all the people out looking at it, because we didn't know the ark was so big. And so they'd go home and they'd dig out their Bibles, the old family Bibles, which nobody had touched for years, and they'd read the story of Noah's Ark. Which is really good. Did I say before that I just watched a video of a young guy who was sort of quite mixed up with trans and all that, who read the story of Noah's flood, and he just was saying just how not challenging, but how mind-changing it was, understanding the world and understanding himself. And so the rocks, fossils, and the age of the earth. Fossils, if there really was a worldwide flood, what would you expect? You'd expect to find fossils, billions of dead things. And here's an example. I think I showed this. Did I show this on Friday evening? This is a ichthyosaur, which is a marine reptile, and it was found in a quarry in Germany, a limestone quarry, and it was immaculately preserved. And it's a female ichthyosaur. I sometimes make a joke as, how can you tell it's a female? You can see the lipstick. Can you see the lipstick that's on there? No, that's not how you tell. You can see it's giving birth to a baby ichthyosaur. Isn't that amazing? I've heard of some difficult births in my time, but not one where somebody's waiting for thousands of years. And this one was frozen in time. And so the age of the earth and fossils are really important. Understanding. Now, when I was in Canada, I came across this website. I went to a museum there, and I went and had a look through the museum, and I discovered this article about the museum. And it's talking about some fossils that they found, and they were on display in the museum. So you can see this picture. It looks like there's a storm brewing, and you can see these animals. They've got these horns on them. And it said on the article, it said this. It says, a herd of centrosaurs, a type of horned dinosaur, drowning in Noah's flood. No, drowning in, what's it say? A flood, millions of years ago, in what is now Alberta, as depicted in this illustration. So there's a big flood in Alberta, millions of years ago, which drowned these dinosaurs. And it says this, they left behind what could be the world's largest dinosaur graveyard. So they're not talking about one dinosaur, they're talking about a herd of dinosaurs being buried in a flood, And it could be the world's largest dinosaur graveyard. So it sounds to me like a bit of a catastrophe, doesn't it to you? Something like it's quite large. And yet they're describing it as if it's just, this sort of thing happens all the time. We often get herds of dinosaurs buried and herds of cattle buried and made into these cattle graveyards. Doesn't work that way at all, does it? And, we've talked about rethinking, reinterpreting the information that comes about. It's easy. Did you know it's easy? I'll show you how it happens. You just watch this part here. A herd of dinosaurs, centrosaurs, it goes on, drowning in Noah's flood 4,500 years ago. So you see how the secular scientists, the secular paleontologists, they've done all the work. They've collected all the fossils. They've written all the reports, but they don't see Noah's flood. And so they say it was millions of years ago. That's their default. And we can just take it and we can just change it. And it makes a lot of sense. I've had secular paleontologists get really upset at me that I'm taking their work and I'm reinterpreting it. They don't like that at all. So that's one really amazing. We've looked at two evidences for the rocks forming quickly. We've looked at some special rocks forming quickly, centrosaurs forming quickly, and here's another amazing evidence that was discovered by this lady here. I don't know if you've heard of this lady. Her name is Mary Schweitzer. Has anybody heard of Mary Schweitzer? A few people have. Mary Schweitzer liked dinosaurs. She worked in a dinosaur laboratory, and they used to bring in dinosaur bones into the place. And the one time they came in with this dinosaur bone of a front leg of a dinosaur, and it was broken because they couldn't fit it on the helicopter. And so as she was handling it, she could smell something odd about it. And when she looked at it, she could see that it was not petrified, that it was like not fresh, but it was still got organic material in it. So she cut it open, took a little sample, and put it on a slide and looked at it under a microscope. And she's just amazed at what she saw. She said, looked at it, and she said it was exactly like looking at a piece of modern bone. She said, but of course, I couldn't believe it. I couldn't believe it. And she said, how could blood cells survive that long? This bone is 70 million years old. So she believed it was old. And she said, how can blood cells survive that long? Isn't it amazing? So that's really the power of the glasses that somebody's wearing, the power of their mindset. And it has to take a change of mind to say, well, maybe the world is not as old as I've been led to believe, as I've thought it was. Do you see how that works? But if the mindset is really strong, she'll say, well, I'll try to figure out how it could survive that long. Here's another example, and then we'll get on to some dating methods, how they work. So I don't know if you've seen this. This is a quarry, not a quarry. It's like a canyon that's cut through material. It's about 1/40th the scale of Grand Canyon. It's a biggish canyon. The walls of the canyon are about 30 meters high. It's about 50 meters across. And you've got this little creek, this little river, this little creek that's running down, the stream running through the canyon. Now, if you came along and saw that and you looked at it, you could think to yourself, okay, what I'm seeing here, this is how the canyon was formed. It took a long time it must have taken a long time to carve this canyon with that creek. And so it must have been, thousands of years. But, this canyon wasn't carved by this creek. People saw how it was carved. And that makes the difference. Once you see it, you can then understand and know how it works. And so in this case, it was the volcanic eruption, where there was an eruption which melted a lot of snow and ice, which was in the crater of this volcano. As a result of melting it, it came rushing down the side like a big mud flow. And they call it, and it came rushing down the side, and it carved this out. Well, I'd like to say it took 1 hour, but it didn't. It took a whole day to carve this out in this particular canyon. So it was once again up at in Portland, near Washington State, and this is the volcano, Mount St. Helens. Mount St. Helens was an amazing event in that it exploded and a lot of people were able to watch what happened. And it changed geological thinking in that people realized that some really big geological things can happen, which we thought take millions of years, and they can happen really quickly. In this case, the volcano blew the whole of its stack off sideways towards us. It blew this way, and as a result of that, later on, a later eruption carved this particular canyon that's there, and you can see it coming down the side. So, do you want to go into some fairly complicated stuff about radioactive dating? Does that sort of sound a good thing to do after lunch? Why not? Why not? I'm going to explain how it works. I get so many emails and questions from people who hear about a latest dating method or something that's dated, and they write in, and it really unsettles them. Please, can you answer this? And it's really simple. It's a very simple answer to it, but I'll explain it in a little bit. You see, when people see about radioactive dating, one of the things that they talk about is the equipment that they use. They use very elaborate mass spectrometers in these laboratories. They work under vacuum. They have various gases in them. They've got a lot of computer equipment which controls them, and they're highly precise. So they talk a lot about the equipment, how amazingly technical it is, how precise it is, this equipment for measuring things. And it is very technical, it is very precise, and it's amazing. There was a geological friend of mine who took me through his laboratory, and he's showing me how he's setting up this amazing mass spectrometer for measuring, for doing radioactive dating. Now, he believes in millions of years. We've had some interesting discussions, but it is very technical and it is very amazing. And I want to point you to another piece of amazing equipment, which is highly accurate, highly precise. Sometimes they cost lots of money. I've seen them being sold for $50,000, but not this one I'm going to show you. But I've seen these sorts of things being sold for lots of money, and people buy them. And then they run into financial trouble and they want to sell them. And so it's very interesting seeing that. So this is what it is. It's a watch. A watch. You can buy these amazing watches. So he's got a really good watch, has he? I saw you pointing at it. That's all right. It must be a good one. Did it cost $50,000? Not that much. But they're usually very accurate. And this is one. I don't think this is an expensive one. And this is a very accurate one. It's got a quartz crystal, and the quartz crystal, it vibrates at 32,768 vibrations per second, hertz. Plus or minus, it's got an accuracy of plus or minus 15 seconds per month, right? So it's a highly accurate timepiece, and so, which is very interesting. So just imagine that you've got one of these timepieces and you're walking into a sporting event and you're coming into this, it's actually the 1,500 meters freestyle event, and you come into this event, right? And here you are, the guy's swimming the 1,500 meters. He's on his last lap. And you watch very carefully. And so when he touches at the end, you look at your watch and there it is. That's the time. You measure the time when he touches at the end of the 1,500 meters. Right? And that's the time. This is the time that is on your watch, 7, 41, and 53 seconds. And so you could go to 53.111 or whatever. It's a highly precise watch. So you've measured it. You've read the timepiece as to when he touched the end of the swimming pool. And so the question is, how long did he take to swim that race? Has anybody got any ideas and any suggestions on how long it took? You don't have any idea? Beg your pardon? You can't... I've been in secondary school, high school classes, and the students have come up, they've really worked hard to come up with an answer in this. I've got some suggestions for you. It was 7, 41, and 53. So just for the 1,500 metres, how many laps are in a 1,500-metre race? There's 30 lengths, right? 30 lengths of a 50-metre pool. So he's 30 lengths. Are you going to say something? Okay. Well, here's some suggestions. 41 minutes and 53 seconds. That would be if he started at 7 o'clock. Well, maybe he started at 5 past 7, 10 past 7, in which case it would take 21 minutes and 53 seconds. Maybe he's a really good swimmer. Maybe it was a world record race. The world record is 14 minutes and 31 seconds. Could it be something else? Do we know that he actually swam every length? Did he swim the whole 50 lengths? Did he touch on each end? We don't know that, do we? So even though we've got a very precise watch, highly precise, and we read the time immediately when he finished, can we know how long he took to swim the race? The answer is it's impossible to know. It's impossible to know because we didn't see it start. We didn't read it when it started, and we didn't watch every lap to make sure he swam them. We didn't count them and make sure that he swam them. So just by measuring the time at the very end, it's impossible to know how long he took. And that's what radioactive dating is. It's measuring something right at now, the end, and we don't know what the beginning was. And so it's impossible to know. And yet they give us this information as if it's a fact. And I think we're being tricked. I think we're being tricked because it's actually impossible to know. And the thing is that geologists know this. They know there's a lot of assumptions. Like you assume, for example, we assume, well, what was the watch reading when he started? How many laps has he swum? Did he touch it every length? You got all these questions that are going through. It's the same with radioactive dating. What was the composition when the rock formed? And has there been any change since? Has there been any loss? Has there been any gain? All these questions, and you got no idea. Has the rate changed? And so you got no idea whether they're true or not. And so geologists know they don't believe the answer unless it fits with what they want. They know the answer that they want. They know where it sort of fits. And we've got an article that talks about this, and I've got a brochure about it, how dating methods work. And it's got a real-life example in there called How It Works in Practice. And that just gives... the thing is, this has been documented by people publishing in scientific papers. They published these results in scientific papers, and then later on people said, oh, there's a problem with that. So they changed the date by taking more measurements. And then somebody says, oh, there's a problem with that, and they change the date again. And so this is a real-life example of how it works. So geologists don't believe it if they don't like the answer. And so it's like when you get a number, it could be quite a few different things. Like we'll get into that, but I'll go into just this article. This article here, it's been published on the web. There it is there, and it's got a little example of a measuring cylinder. It's very simple, but I've had a lot of fun with this article when I've spoken to different groups. And I ask them questions, and it really illustrates how dating methods work. And by the end of it, they know for sure that it can't know. It's just being sort of, the numbers are coming out. Geologists are getting the numbers which suit what they think it should be, and when they publish it, everybody thinks, isn't that amazing? How do they do that? Do you see? So these are the take-home points from this article. So this is the first one. No instrument can measure the age. Now, this might be surprising to you, There is no instrument that can measure the age of a rock. Now, why is that true? Can somebody tell me why that is true? Why is that a fact? We've sort of talked about it a lot, but there is no, when they come up with an age, you say, well, there is no instrument that can measure the age. I don't believe that. But why is that true? Why is there no instrument that can measure the age? They have to assume something. They can only measure things in the present. So that's all they can measure. They're making measurements in the present. And they need to have measurements in the past, and you can't go back in time to make the measurements in the past. And so, even though there's these instruments that make the measurement, they're not measuring age. And so there is no instrument that can measure the age. Do you see how it's all to do with the thing that happened in the past, and we can't go back in the past. So that's the first one. There is no instrument that can measure age. And geologists know that. And so this is the next thing. So how do they get a number? How are they able to do a calculation? Well, you have to assume what it was. What time did the swimming race start at? Did it start at 7 o'clock? Or was it 10 past 7? Do you see? They have to make an assumption. And so all dating methods are based on assumptions. They're all based on assumptions. They give the impression that they're based on measurements, accurate measurements, but in actual fact, they're based on assumptions. And I think this is a really important thing. If you know this, it's very liberating. And the next one, you can get any age you like depending on the assumptions you make. Did he start at 7 o'clock? 10 past 7? You can make him into a world record and then publish it because you assume what time he started. Do you see how that worked? And the last one is geologists do not accept dates that don't affect their expectations. And so they get a date and they think, oh, well, this date should be about 100 million years. Oh, this is 200 million years. Oh, okay, that must be because, they've got some stuff which has come out of this volcano and it's done this and done that. And so they come up with a story as to why it's 100 million years is not the date that it should be. Do you see? They make up a story to explain the dates away. But if the date comes out around about where they want it, which is a big range, they can say, the date is, and we measured it, this is what it was, 199.9 million years. See, that's how it works. Do you like that? I don't know. Has that been interesting? I hope it has. I'll give you just one example. This is a rock which somebody collected. It's a volcanic rock, and they broke a piece off it and crushed it up and sent it off to the laboratory to be tested. So what the laboratory does, it analyzes it and it makes standard assumptions. So there's various standard assumptions that they make, and so that from that they calculated an age. And so they took the whole rock, crushed it up into little small pieces and sent it off. And it came back with an age of 350 million years. No, 350,000 years, right? 350,000 years. And so that's pretty simple. But what the guy did, he broke another chunk off the rock and he crushed it up and he picked out a little white mineral which was in the rock. So it had different minerals in it. He picked out this white mineral with tweezers and a magnifying glass and he made a sample of the white mineral and he sent that off to the laboratory. So they did the same thing. They measured the radioactivity in it and they made the standard assumptions and it came up with 900,000 years for the mineral in the rock. And so then he broke another chunk off and it was, he picked out the black mineral, which is pyroxene. He sent that off to the lab and it came back with an age of 2,800,000 years. And so the question is, what age is the rock? And so you could make up a story about this, and that's what geologists do. They make up a story, and that's what they have to do. They publish a paper, they go through and explain what they do, and then they have got a little section which is called My Story. Well, it's actually called interpretation, but that is really their story as to which dates you should believe and which dates you shouldn't and why, right? So every date is based on an interpretation. And there was a guy who was a very famous in radioactive dating and that, and his name was something like Wasserman, and he lived in Germany. He was really a pioneer of it. And he said, there's no such thing as a bad radioactive date. There's no such thing. The only thing is there's bad interpretations. In other words, you can't get the wrong answer. You just change your interpretation. So there we go. So this rock, what are you going to do with it? Well, in actual fact, they saw this rock form. It was a result, Mount St. Helens again. After this big eruption, it pushed up the lava into the lava dome and formed this lava dome here. And somebody actually went up and collected a sample of the rock, and that's what they tested. And it was 10 years old. 10 years. And gave an age of 2,800,000 years. So is it possible to know the age of something? I know my age. Do you know your age? How do you know your age? I was once had a young lad in the audience here, and I said, so how old are you, sonny? And he said, I'm 8. I said, oh, 8, okay. How do you know that? He says, oh, it's written on the calendar. I said, oh, how do you know that's right? Oh, Dad wrote it there. So how does he know? It was so interesting watching his head, trying to figure out how you know. I said, do you remember when it was? And finally his dad said, his mother was there at the time, you know. And so how do you know? It's eyewitnesses, a historical record. That's how we know what happened in the past. It's a sure way. Eyewitnesses, people who saw it, and a written record, a birth certificate. And that's how we know. And that's how we know things in the past. For example, the first fleet arriving in Australia. How do we know that? Oh, we did carbon dating on the ship. No. Basically, there were people who saw it. They wrote it down in their diaries. They wrote it in letters, and they put it in their logs. And so it's all sort of written down. It's reported. And so we know the age. So how do we know the age of the earth? Now, take notice of this. Take notice of this, because I get asked so many times, how do you know the age of the earth? How do you know? How do you know? Well, we know because of what's recorded in the Bible. The Bible has got some amazing genealogies. You know those parts of the Bible you just can't put down when you read them? Adam was so many years old and he begat Seth, and Seth was so... You just can't put it down, can you? Hey? It puts you to sleep. Is that the way it goes? But you know, the amazing thing is, this is just a diagram of the genealogies from Adam up there, goes through in the red, through, and then it goes down to, there's David down there, and then eventually to Christ. It breaks into 2. So Adam was so many years old, and he gets Seth, and Seth would get Enosh, and goes to Noah, and then through Abraham. So this is history. That's how we know, because, and they record in the Bible that Abraham used to tell lies. He was married to his half-sister. They recorded how they had trouble having children. You know, all this history, events which happened in their lives, it's not made up. And so from this genealogy, you can easily calculate how long it was between Adam and all the way to Christ. There are 2 lines going to Christ. One goes through Mary, and another one goes through Joseph. Joseph was not his real father, but that's how you trace it through. Isn't that amazing? So now you know how you figure out the age of the earth. It's about 6,000 years old from that. And it's the only reliable, the only definite, sure way of knowing the age of anything. Now, if you really want to know, you go to creation.com and you write the Archbishop James Ussher, and that'll explain to you how you calculate the age of the earth. And other people have done similar, and it sort of get pretty well the same answer. Not exactly, but pretty well the same. There's a few things that you have to assume, but not very much. So it's been a wonderful journey. Last night, this morning, and now, and we've learned. I hope we've learned lots of new things. I hope it's helped us to become more confident and competent. And I hope it's sort of, ultimately what it's about is a transformation. As we gain knowledge, it transforms our way of looking at the world. It transforms the way we feel about ourselves. It transforms our confidence in that. And that's why I get a bit excited about encouraging you to get informed. Now, I've mentioned a lot of things, like there's this things here, the Answers book. That would be very helpful. And the Evolution's Achilles' Heels, I've talked about that. There's this other book I don't think I've mentioned, Biblical Geology 101. That book explains how you can figure out what rocks formed at what part of history, biblical history. And it's really interesting the way it goes into it. And there's a couple of good authors there. Michael Ord and Robert Carter has done that. And I've already explained how to get the Creation magazine. And so I just want to encourage you to sort of say, okay, I'm going to do something about this. And I can't convince you to do it, but it's as you see a need and as the benefit of this can actually transform your whole outlook on the Bible and on life and the way you relate to others. I met a guy, or I heard of a guy who said this. He said, I was converted when somebody gave me a copy of Creation magazine. So that's how he came to the Lord. And he said, I've subscribed for five of my relatives, and he says 4 of them have come to the Lord. And have you had Ron Neller here, haven't you? Ron Neller has been here. He's a guy who he was not a Christian. He was a geologist. They're not incompatible, but he was a geologist. He came to the Lord as a mature age person, and he came from a family background where there were no Christians in his family. And so he's been working with Creation Ministries probably for, 10 years or something like that. And I've been inspired by him because he's got the Creation magazine. When he gets one, he reads it and he gives it to a relative. And he says, not all my relatives have been very happy with me giving them to them, They get these bad looks. But he's persisted in a very loving way. And over that 10-year period, quite a number of his relatives have come to know the Lord. And I think we've got to be, I wouldn't say pushy, but we've got to be a bit more vulnerable ourselves in sort of stepping out and sharing things. When I heard Ron Neller tell me this, I was on, an email exchange on the, on the computer talking to him. And I got off the computer and I started subscribing for my grandchildren. I've got 18 grandchildren. And anyway, one of the grandkids that I subscribed for, I said, would you like me to subscribe? I'd like to do this. He said, oh, Granddad, that would be great. And so I subscribed for him. And what happened was, just recently, he sent me an email and it had a photograph. He'd taken a photograph. It's arrived, which I thought was really good. So you can do a lot of good stuff. And I think it's good to get this into the hands of people. So that's, and I've shown you how to subscribe, filling out that form, 1 year, 2 years. Why just stick with 1 year? 2 years is cheaper, and I think you get a lot of goodies with it as well. So that's, we have, what have we got? We've got about 10 minutes, is that right? Five minutes, does that mean 10 minutes? Yeah, okay. So, I just want to open it up for questions. When we opened it up for questions last night, people were so shy at the beginning. But once it got going, we couldn't stop it. Did you notice that? So we only got 10 minutes. So if anybody's got any questions, I'm happy to talk to you, happy to try to answer. And then after that, when it's over, as we go out and you get your stuff, we can chat to you then. Anybody got any questions? Yes? Start it off. We need somebody to start it off.
After the flood, where did all the water go?
Where did all the water go? Well, it's to do with the movements in the Earth's crust. We had the great big earthquake off Japan, which caused a tsunami. So the Earth's crust at that time moved about 15 meters, and it tipped the water up. And so during the flood, it was a lot of movements in the Earth's crust, and you can see the evidence of this in the rocks. You can see the geologic maps, and the geologists can map how much the Earth's crust moved. So geologists sort of say or recognize that the continents have lifted up. They talk about the uplift of the continents, and so that also involves the relative downlift of the ocean basins. So as the waters reached the peak, and this would have been about the middle of the Cretaceous, which is the geologists would call that 50 million years ago. That's what they would say, but it was in the second half of the flood. That's when the continent started to lift up and the ocean basin started to sink down. So what happened was the water ran off the continents, and you find that, of course, in Australia, for example, it runs in all directions from the middle of Australia. It runs, some goes out to the east, some goes to the west, some goes to the south. And you can see the patterns in the landscape as the waters ran off. As a matter of fact, if you go to Google Earth, you can see large sand waves in the middle of Australia as the water was making these sand waves. If you go to Alice Springs and that, you can see these mountain ranges. You've got these big mountain ranges, and you can see these rivers go straight through the mountains ranges. How do they do that? That's because they once covered these ranges, and as the water flowed down, they cut themselves down. And so there's a lot of amazing things that happen. So basically the water went back into the ocean. A long answer to a short question. There you go. Anybody else? Yes?
People that believe in evolution, they're not to be treated as foolish or simple-minded. They're quite often very intelligent people.
Yes.
What's the best example, or what's the best way that we can approach an alternative argument for creation without offending them, without treating them or belittling them?
Yeah, well, I don't know if you heard the question. This gentleman sort of said, people that believe in evolution, they're not dumb. They're very intelligent people, and that's right. And I would say if evolution is the best explanation that there is for how everything came about if there was no God that created. If everything came about by natural processes, that is the best explanation that you could possibly come up with. And so I was talking to a guy last night on Zoom, a guy from China, and I don't think he had much of a Christian heritage. And I was just presenting evidence for rocks forming quickly. And you could see him scratching his head and sort of, well, how did it form if it formed quickly? Because we read in Hebrews, by faith we understand that the universe was formed at God's command, so that what is seen was not made out of what was visible. And that is the really hard thing. We can't imagine stuff being made from the invisible. And so I think it gives an understanding. You can't prove that creation's true, but you can sort of say, well, there are problems with it, but if you want to know, it's a matter of opening your mind to thinking that this is possible. So I think if a person's open, it's fine. If they're closed, you have to try a different approach. I got a good story about that, but I won't go into that, about somebody who was arguing, and I tried a different approach. But anyway, let's go on with another question. Yes? So shouldn't things be devolving? Evolving still. That's right.
So like for instance, if it's evolution, there should be evolution happening in front of our eyes, because things come in obviously different stages. So we should be seeing evolution.
You should be seeing evolution happening. They would argue, like when you're in a conversation like this, in a way, no matter almost what arguments you put up, and I think it's good to put up reasons and arguments, I think it's good, but don't be sort of disappointed if they come back and say, well, that's because, and they can think on their feet, and that's because it happened so slowly, we can't see it happening now. you know. And the same thing happens. It's happening so slowly we can't see it happening. And other people say, well, you know, what about these fossils in the past? They just are missing. Oh, well, it happened so fast that you didn't leave any fossil traces. So it's interesting. I don't know, but you're right. That's a good. I would put that argument and say that to a person. But I would also encourage a person, say, you know, you can know. It's not you don't really come to know God through your mind. You know, there is evidence and we hear things and that, but ultimately it's a matter of asking him to reveal himself to us. And so if you know, you can do that now. You don't have to go through all this. Yeah.
But as I discussed with you before, I mean, there's cells and there's nucleuses in our body that cannot evolve.
That's right.
It's impossible for them to evolve, or impossible for a central nucleus to evolve into something, because it needs something to survive.
That's right.
So it makes no sense.
So how can you evolve a flower if you don't have a bee? You know what I mean? And so where did the first life come from? That sort of thing. So, okay. So anybody else got a question? Are you all creationed out? Yeah? You got a question?
If you look at the moon, the part of the moon that's closest to Earth has a lot of craters, but if you look on the other side of the moon, there aren't as many. Do you think that's from the fountains of the Great Deep, and maybe lots of rocks have flung out really hard?
So if you look at the moon, the side that faces us has got a lot of craters on it, which looks like the man in the moon. And on the other side, which has only been sort of explored in the, you know, since satellites have gone past it, it has hardly any. It has a couple, but not many. And you said, is that because of the fountains of the Great Deep blasting rocks out, blasting stuff out into space and causing these impacts on the moon? Some people have suggested that. Other people have suggested that it was some sort of meteorite swarm that was coming through the solar system. And you find similar craters on Mars and other planets in the solar system. And because they're on one side, it suggests that perhaps this was a restricted swarm of very large meteorites. Some of those craters are enormous on the moon. And so they all happened within a period of a couple of weeks because the moon rotates around once a month. And so if it happened just irregularly, you'd expect it to be random. But since they're all so close together, it seems like it happened, you know, within just a restricted period of time. Okay. Another question. And there.
I was just curious to know what are some of the worst arguments you can use when you're speaking with an evolutionist.
The worst arguments, I think the worst thing you do is get angry. I think that's the worst thing you can do. I think the best thing to do is to ask questions, you know, and that's something I found very hard to learn to do, to practice to do. I think it's really important to ask questions and say, oh, that's interesting. Why do you think that? You know what I mean? Instead of saying, that's stupid, you know, that's not right. So I think you've got to ask questions. And I heard a story about a guy who was a lecturer at a university, and he gave a series of lectures about evolution, special two lectures. And there was a young Christian girl went along, and she asked to see him. And so she visited his room, and after, I think, the second lecture, and she asked him, had all these questions that she asked. And he gave the answers to the questions. And he said that while I was giving her the answers, I was thinking to myself, that's a stupid answer. That's what he was thinking. He was telling her an answer, but in his mind he was thinking, that's a stupid answer. And that caused him to go on a journey, and he became a Christian and became a creationist, and he's sort of written a lot. But I thought that was interesting, is that just because people resist what you say doesn't mean to say they're not listening or not being challenged. So it's a pretty exciting thing to be on, really. Okay, it's 3:00. I can go on for another. You have another question?
With OpenAI becoming knowledge is available on OpenAI, you can take your questions and put it in AI and see what they say.
OpenAI is quite good. I've had a lot of fun with AI. So I asked it, for example, I said, how is gold formed on the earth? So I was researching gold. How is gold formed? And it came up with this explanation. That's a good question, blah, blah, blah. And it went into all the stuff about how gold was formed, which was the evolutionary explanation. Millions of years ago, billions of years, it goes into all this. And I said, thank you very much. That's really good. I noticed that you've given the explanation from a long-age evolutionary point of view. Can you please give me an explanation from a young earth creationist point of view? And it comes back and it says, certainly, no problem. And so it came and gave an explanation from a young earth creationist point of view, and it was very good. It quoted, people that I knew and that sort of thing. It was very, very well done from a creationist point of view. And then I said, so when I asked the question, I said, why didn't you give me both views? That's what I said. And he says, because we detected that you sort of had, and it went into a story. But generally, it gives you the information that it thinks you're going to like. And so if you ask it in a nice way about something from a creationist perspective, it often gives you something quite reasonable. Okay, so I think we might just give thanks, I just want to say thank you very much for the wonderful opportunity it has to be able to share with you. That's 4 occasions, and so that's quite a few hours of opportunity to talk. I don't get that sort of opportunity in my own church to talk like that. So it's really good to be here, and I thank you very much for the opportunity to share. And I know that you're enthusiastic, so that's good. So, Pastor, I appreciate you inviting us, and it's been really, really excellent. I don't know what time I was supposed to finish. I think about now, wasn't it?
Thank you, Taz. We started yesterday, last night, and then this morning, and we've come to an end.
Thank you
It
is
so
sad,
much.
isn't it? It is sad.
Thank you so much, and it's an ongoing thing, intersection of Bible and science, and there is so much out there, and you have given us 101, and just to bring us into that debate and into that sphere, and it's obviously a wedge into so many people who are seekers out there for the truth, and we live in a world where the fight for the truth is very real, and opposition is very, very fierce at the same time. But thank you for being a champion of the word and champion for what we believe, and it is way more superior than those who are without hope. And thank you so much. Let's have a prayer, and
Thank you for that. Thank you for your prayers. I like your prayers.
yes, let's pray. Father God, we just want to thank you for Taz and for his ministry and for life of dedication to your word and to also scientific approach. And Lord, we believe that you are God of creation, and it is not coincidence that the science has come from the bosom of Christianity, and but then it got sidetracked. And so, Lord, we pray that we will be people of intellect who are asking questions and are always open to understand more and more, and help us always to be honest, and at the same time help us, Lord, to be faithful to the good news and to your word. I pray that you will bless us and be with him in his ministry, and continue to guide him and endow him with wisdom. We thank you for that in the name of Jesus. Amen.
Amen. Thank you.
Why don't we put hands together for Taz and his
Thank
ministry?
you. It's been good.
Thank
It's been
you.
really good. That was fun, wasn't it?
I'm going to send you a link. I remember 6 months ago,